All right, let's go and get started. Uh, I'm going to let me put this device in. So we will be discussing control structures. Hang on one second. Okay, so we'll be discussing control structures, and the control structures are basically two types. One is the conditional control structure. We also call them selection in chapter 4, and in chapter number 5, we'll talk about another control structure is called repetition or looping. I think this chapter will take maybe 30, 35, 40 minutes or so. Then I'll talk about the project associated with this project. We'll talk about if and else. If you remember, we did use if and else in one of the projects in chapter number 2 or project number 2. So we'll be officially discussing if and else and what are some of the Boolean data types used within if and else. How do we do string conditional checking? Can we compare strings and textual data? We'll talk about that one. And finally, there's another control structure called switch in case. We'll talk about switch in case briefly at the end of chapter number 4. All right. So the computer can proceed in sequential order. That's what we learned in the first and second project. Then in chapter 4, we'll learn about making a choice and branching out, or called selection or conditional control structure. In chapter number 5, we'll talk about something called repetition or iteration, or we also call them looping. And chapter 6, we'll talk about functions. So the two more common control structures are selection and repetition, which is chapter 4 and chapter 5. These are called the heart of the programming. This is gives you the raw power, how to figure things out when you have multiple choices you have to make. So here you have an expression. This particular symbol shows an expression. This, if the expression is true, do this. On the right hand side, if the expression is false, do something else. That's your selection control structure. The sequence is just sequentially execute the statements in a specific order. In chapter number 5, we'll learn about if there's an expression, could be true or false. If it's true, continue to repeat that expression until it becomes false. That will be a repetition control structure. So execution of selection repetition requires a logical expression. The logical expression can only be true or false. Those are the two options. For example, this is a logical expression. 8 is greater than 3. This particular expression is true. And based on this expression, we can actually execute certain lines of code, or we can branch out in a certain way. Now we have 6 relational operators to check those expressions. We have equal. Now notice that this one is double equal. Double equal in C++, Java, C Sharp, and C, it means equality. So this means equal. The single equal is not equality in programming in most of the languages. Single equal means assignment, assigning a data to a variable. This one is not equal, the exclamation mark and equal sign. This one is less than equal, and greater than equal. Okay, so we'll be using all 6 relational operators in our coding. And the conditional statements only execute if certain conditions are met. And those are driven by the Boolean expressions. Boolean expressions, they only give you true or false. And again, once we get to our demonstration, it will make a lot of sense. What it's saying is that you can only reach true or false. And in order to check the left side and the right side, you use some kind of operator in the middle. And those operators allow us to compare values. So you can do comparisons. You can actually have 2 operands. Operands means you have something on the left-hand side and right-hand side, and they evaluate to true or false. Take a look at this one. 8 is less than 15. This is true. 6 is not equal to 6. That is false. 2.5 is greater than 5.8. That is false. 5.9 is less than 7.5. That is true. So these are some of the usage of relational operators. Expression of char values with relational operators are also possible. For example, you can check R, uppercase R is greater than uppercase T, although this is false, but you can check such an expression. Similarly, you can check individual value like 4 is less than 6. So these logical operation expressions return an integer value of 1. 1 means true. And if the value actually is false, then it returns 0. All right, this is called one-way selection. One-way selection in C++, Java, C#, and C, you put the condition or expression inside the parentheses. For our sake, we will also using the curly braces to show the body of that particular statement. Although if you only have one statement, you do not need the curly braces, but for our class and for our understanding, we'll be using curly braces regardless. All right, so if this expression is true, this particular statement will be executed. And if the condition is false, this expression is false, then the statement is bypassed if the value is false. And this expression is called the decision maker. Okay, and it can be demonstrated here in this particular case. Sometimes you have two-way selection, and with two-way selection, you use something called else. Now, else cannot be used by itself. Else must accompany with if. So if actually dictates else. So if this expression becomes true, statement 1 will be executed. If the expression is false, then it jumps into the else part, and the statement 2 will be executed. Okay? All right, let's look at some of the more examples. And this flowchart shows if expression is true, do statement 1, expression is false, do statement number 2. Earlier versions of C++ did not provide built-in data types that had Boolean values. Logical expressions evaluate to either 1 or 0. But now we can use int data type to manipulate logical expressions as well. The data type Boolean has a logical values true and false. True and false are reserved words. In fact, all three of them, Boolean, true, and false, are reserved words. True literally means 1 behind the C, and false means 0. And then we have, just like relational operators, we have 6 of them. We have something called logical operators. We have 3 of these logical operators. Exclamation operator by itself means not. This and ampersand sign, 2 of them without space in between, is called and operator. And this is a pipe symbol, or you can find this particular symbol right above the enter key on your keyboard. This is called or operator. These 3 are called logical operators. Logical operators allow us to combine logical expressions. So if you have multiple conditions you have to check, condition 1 and condition 2 be true, then you have to use AND operator, which looks like this. If you just have to check OR operation, so if condition 1 or condition 2, then you can use this particular operator. Okay. Now these are called these are basically truth tables, and this is a truth table for not operator. If the expression is true, and if you're using the not operator, if you convert into false. So this expression becomes false, and vice versa. In case of AND, all the conditions must be true in order to get the result as true. So first condition and second condition must be true in order to have the result as true. If the first one is true, second is false, the result is false. If the first one is false, the second is true, result is false. If both conditions or all conditions are false, the result is false. So AND operator is very restrictive. It wants all the expressions, all the conditions must be true in order to get the true result. OR is more lenient. OR is very lenient. In case of OR, if the first expression is true, the second is true, the result is true. The first one is true, the compiler does not even waste time and check the second condition because it doesn't need to check the second condition, the result will be true. If the first one is false, the second is true, the result is true. The only time OR operator becomes false when all the conditions are false. Okay, so the rational and logical operators are evaluated from left to right, and parentheses can allow us to override the precedence. So in the next chart, you will see what are some of the operators and their precedence or their priority comes. So you can see these unary operators, they have higher precedence than most of the other operators, like not operator, positive, negative, plus and minus. They have the first precedence. Then multiplication, division, and modulus operator have the second precedence. Notice that if you continue to go in that direction, AND operator comes first, then OR operator, then assignment operator. And this kind of table is going to continue to grow when we learn about more additional operators as well. All right, how do you declare a Boolean? I have mentioned this one to you earlier as well, but in the previous chapter, but here you can create a variable called found, which is a Boolean type. You can assign a value of true, or you can assign a value of false based on your logic. And here, not found, it becomes false. If it was assigned true here, and when you say not found, it is false. Hours are greater than 40, not age. So if you look at the value of age here is 20. If it's not 20, it becomes false. Okay. And we'll be comparing two types of expressions on each side of the equation. So here you can see two conditions, count is greater than 0 and count is less than 100. So it means the range between those two. So we are applying the AND operator. And if the value is between those two ranges, then the AND operator will dictate and it will give you the overall correct answer. Similarly, it can be also applied with the characters, and the AND operator can be applied to characters in this particular case. And I'll be demonstrating all these things to you once I get to that point. Relation operators can be applied to strings as well. Strings are compared character by character, starting from the left-hand side. And the compiler looks at the ASCII value of each one of those characters. Comparison continues until there's a mismatch. If two strings of different lengths are compared, and the comparison is equal to the last character of the shorter character string, the shorter string is less than the larger character. For example, you're comparing Joe with Joseph, and the shorter character is less than the larger character because Joseph has additional characters in there. And this is, take a look at these strings here. It's going to show you some of the comparisons between these strings, and it talks more about it. And when you read the chapter, it's going to make a little bit more sense. I don't have to go in detail because I'll be demonstrating these things once I get to the demonstration part. Then we can also do compound statement. Compound statement, I actually prefer the curly braces. If you remember when I talked about if statement in the beginning of the chapter, I did say that you must use the curly braces regardless you have one statement underneath or multiple statements. So we are going to use curly braces regardless. But if you have curly braces and multiple statements, that is called compound statement. All right, so here is, if age is greater than 18, this is a compound statement, we'll do these two things. Else, if this is false, if this condition is false, we get to the else part, then we'll actually run these two statements. Okay, and nesting is when one control structure is embedded in another control structure. And we'll see some of the examples. And in fact, you're going to recognize this one very well. We did something similar. In fact, we did exactly similar the thing in project number 2. In project number 2, when we did the comparison for average, we actually did if average is greater than 90, then grade is A. Else if average is greater than 80, the grade is B. In fact, we don't have to check the AND operator here greater than 80 and less than 90 because you already failed the top condition here. That's how you got to the 80, the second level. So if you put the AND operator and check the second condition, it's just a waste of resources because you already failed this condition. It was not greater than 90. That's why you got it to this point here. So, and this can also compare months, for example, in this case. And it shows you another example with if this one actually shows if analysis. This is preferred. This one actually doesn't have if analysis. This one actually is more time consuming. Yeah, I would say time consuming and resource wasting resources because this one, it has to check every single condition. On the other hand, if the first condition is met, it's going to ignore the second, third, fourth, fifth, all the rest of the conditions. So this particular structure in slide number 36 is more efficient than structure on slide number 37. Now, I alluded to this one. Short circuit evaluation means in case of OR, I can see this is an OR operator. If this condition is true, we don't even have to check the second condition. That's waste of resources because in case of OR, only one condition needs to be true. In case of AND, if the first one is false, it doesn't really need to check the second condition because in case of AND, all conditions must be true. So what the compiler does not execute unnecessary steps if it finds out certain operators are being involved. And it just shows you the comparison between these numbers. I don't need to go into detail here. Here it's asking for an integer. If the integer is less than 0, I do not like the way it is shown over here. I will show you a different way and better way to how to compare numbers between 0 and 10. In fact, I would preferably use two variables, number before and number later. But the author in this case is showing you it this way as well. And it's showing the values with the value is 5, and this is what will happen. Must use concept techniques correctly, otherwise solution will be either incorrect or deficient. If you do not understand a concept or technique completely, don't use it. Save yourself for trouble later on. All right, so input failure and if statement. If input stream enters a failed state, all subsequent input streams associated with that stream are ignored. And we talked about this one in the last chapter as well. Sometimes the input stream goes to the failed state because of what kind of data we are executing or evaluating. So if x equals to 5, this is actually not a good condition checking because this is basically means assign 5 to x. When you assign any non-zero value to a variable, it is always true. Although you thought you're comparing these numbers, this is not a comparison. This is basically assignment. So this is actually a logical error. You should have used this operator. This is the one which basically uses the equality or checks the equality. And that's what the book is saying. The appearance of single equal in place of double equal resembles a silent killer because it's not a syntax error, it is a logical error because you were supposed to have two equals right here. All right. And then we have something called ternary operator. Ternary operator actually checks the condition and evaluate the answer within one line of code instead of multiple lines. Although I never use it, it's available in C++. So this is where the condition is. If A is greater than or equal to B, then do this. Or assign A to maximum. Otherwise, if this is not true, assign B to the maximum variable. So this kind of expression you can do in just one line instead of multiple lines. The indentation is highly recommended. Be generous with the indentation. In fact, it's more readable, and also you can avoid so many errors by using indentation. And I actually am very generous with indentation as well as spaces. Now, something else which is discussed here is the pseudocode. Pseudocode is basically English-like structure. So when you are trying to solve a complex problem, it is widely recommended that you use some kind of that logic in English-like structure in that particular language. In that way, you can convert easily into a programming language such as C++ or Java. This pseudocode does not require any technical background. It just needs to be presented in a way that which can be converted into machine language, or sorry, the programming language. Finally, we have another structure at the end of the chapter, which is called switch case. Switch structure is kind of not really alternative to if and else, but it can be used for certain cases. This is what it looks like, and we'll see an example and a demonstration as well. There's some restriction with switch case. The switch case cannot evaluate an expression which is either double data type or string data type. So if you have a simpler data type such as integers and characters, switch case is perfect for those kind of data types. And this is what the switch case flowchart is. Um, then you also have another restriction in switch case is the break statement, and I'll demonstrate the break statement to you. And also we have some demo files already available on our Canvas side. So for example, if the incoming data is grade, if the grade is A, then it will display the grade point average is GPA is 4.0, and then you need a break statement to exit this structure. And unfortunately, this is the restriction that you have to put a break statement after every case. So you have multiple cases. So the incoming data of a grade must be of certain type. Like I stated, it cannot be of string type or it cannot be a double data type. It has to be integer or character. In this case, the grade is character. Now, if the first case is false, then it checks the second case. If the second case is false, it checks the third case. If the third is false, fourth checks the fourth one. Finally, if all these cases are false, then it goes to the default case, which is the grade is invalid. So if the incoming value is not A, B, C, D, and F, then it will basically display the message invalid value. So switch structure must include a break statement after each cout statement, like I stated. Certain types of errors are very difficult to catch. And for example, division by zero. So in that case, there's a function called assert function. And assert function belongs to C assert library. I personally do not like it, but it's there, it's available. What it does, it basically forces you to exit that system at that time. This is what assert looks like. And I discourage to use the assert function because there are better ways to use to manage it. And in fact, I showed you in chapter 3 how you can actually check if the data is invalid, and you can actually uh, clear the bad state, and you can ask the user for a good value again. Even in the runtime, you want to anticipate as a developer, and even if the computer has a runtime error, you do not want to exit the system. Imagine if you exit the system for a bank or Amazon or airline company, that will be really devastating for that company's revenues. In order to use assert function, you have to use C assert library. You have to include that library above the main function. So assert is useful for enforcing programming constraint during the program development. After developing and testing a program, remove or disable the assert function. I don't use it. I don't recommend it. So, but it's something it's available to you. All right. Now what I'm going to do, I'm going to do a demo for you. So let me exit this part here. And let me see if um, I can show you. Let me just go here first. So we have project number 4. I'll be showing you project number 4 as well. And let me just show you the project number 4 first. And in project number 4, we will be calculating the quadratic equation. And with that knowledge, once I do the demonstration, everything will make sense to you. So I do recommend in project number 4, you calculate the inner part first separately, b squared minus 4ac, call it discriminant or some kind of assigned to a variable. And because the value inside the square root, if it's negative, we do not have an answer for that one. And that is called imaginary solution. If the value is positive, then we can easily take a square root of that one. So for example, if the value is positive, then the quadratic equation has two parts. This part here with the plus sign here, and this is with the minus sign here. So you need to calculate both parts of the equations. And notice that 2a is dividing, the denominator is dividing the whole numerator. I do recommend you calculate this one first. You calculate b squared minus 4ac first. If this value is greater than 0, it means it's positive. Then it means you're going to get two positive or two real solutions in that case. If the value in here is, after you do the square root, if it's 0, then it means you're going to get one real solution. In both cases, you're going to get minus b divided by 2a, only one real solution. If the value in here is negative, then you'll get two imaginary solutions. And we'll see in the second page what they look like. And if the value of a is 0, then you will display, sorry, the solution is not possible. Let's go look at the value of a equals to 0 here in the solution set on the second page. Notice that the user is going to give us the value for a, b, and c right there. And if the user gives you 0, so you will display a message, sorry, no solutions are possible in this particular case because we cannot calculate something which is when the denominator is 0. If the values are such as, then it's going to give you positive solution or two real solutions. Your answer should be like this one. And these are displayed in a scientific notation. If the value of the discriminant inside the square root is 0, then you'll get just exactly one answer, one real solution for both of those equations. If the value is negative, then you will get two solutions. And because inside the square root, there's minus value, so you indicate by I or iota. All right, I'm going to demonstrate how that is done. And let me go and show you. And I will open up the compiler. You just can simply open the compiler here. There you go. You can close that one, make more space here, get rid of this part here. I don't need this anymore. And I'm going to include C math library. Right? So far, so good. Now, let's take a look at, let me use some of the data from the quadratic equation problem or project number 4. So in project number 4, we have, I recommend you declare all of them as double. So, and initialize them as double as well, 0, 0.0. So I'm going to copy this one and change that to B, change that to C, change that to discriminant. Okay. So after we have declared those, I'm going to ask the user, enter the values for A, B, and C. So user will provide us those values, and I see how easy it is. Although I discourage to take these inputs all at the same time, but in this particular case, if we are following the handout, the instructions, then you can do so. But if you prefer to get the value separately, that's perfectly fine as well. Now, the first thing you want to do, if the value of A is provided as 0, you immediately want to say, sorry, no solutions are possible, and you stop the program. If the value for A and B and C are non-zero, especially for A is non-zero, then you can continue and you can process it. Now, how do I calculate B squared minus 4AC? Well, you can simply B times B minus 4 times A times C. That will be a discriminant. So let's assume, again, just for sake of simplicity, because I want you to do your own work, let's assume the value of discriminant is minus 7. If it's minus 7, by the way, how do I get minus 7? If you look at the values here, 2, minus 5, and 4, and if you plug in those values in the equation, B squared minus 4AC, it's going to give you minus 7. You can do the calculations. Now, if I try to take a square root of this one, because I'm using a C math library, and if I say, show me the square root of SQRT discriminant, and show me this value, and if I run the code, and if I say, oh, okay, it's asking for value 2 minus 5 and 4. And it says this value. This value means it's unable to calculate. It's not able to calculate the value of discriminant because it's a -7. So how do I do that? So in order to do that, what you can do, you in your code, you remember because this was negative value, and you can say, well, if discriminant is less than 0, in our case, it is. That's the case, then I cannot really calculate this particular value is my compound statement. I'm going to convert this discriminant equals to discriminant times -1. Although there's another absolute function available, but this is, if you do that, if you run your code, you're going to get this value here, 2.645. And if you go back to the code again, 2.654, and if you divide by 2a, 2a is, in our case, 2a will be 2 times 2 is 4. Divide that value by 4, you will end up with this solution here. You'll end up with this solution. And because we converted this forcefully by multiplying with -1, so I want to display that answer with something like this, multiplied by I. So if I run the code again, and now you will see this multiplied by I. Okay, so I'm just showing you how you can use this one. So having said that, let me demonstrate a few other things for you. So how do I use, let me declare a variable called int age, and let's just keep it simple. Age is 18. And if I want to check the age, I can say if age is greater or equal to 18. If that's the case, then we want to display you are legal now. All right, and put ENDL at the end. If that's not the case, else if display not yet. Oh, sorry. This should not be. This should be here. See out. Not yet. ENDL. And I actually prefer to have a curly brace here as well. Okay, so let's test it. In our case, the age is 18. So here we're saying greater or equal to 18. So it should say this. Let's verify it. And it says you're legal now. All right, let me change this age to 17. So when somebody is, the condition is not matched here, then I run the code and it says not yet. What if I want to check multiple conditions? I want to check if age is valid or not valid. So what if somebody gives me an age which is 0 or -5? Somebody gives me like that one. Then I can also check right there, else if age is less than 0, I can say invalid age, invalid value. All right, if I run the code again, this time its age is -5, it says invalid value. And I can expand this one. I can expand this one to more conditions as well. I can have more else ifs, and I can say if age is greater or equal to 65, then we can say senior. And let's check that statement as well. So now if I change that to age to 65, now notice that this one, anything above 18, it's going to say you're legal now. I don't want to say that. I want to restrict it. So I can maybe make this one exactly 18. Or I can say, well, greater than 18 and less than age less than 65. So in that case, I can actually restrict my conditions. Now I'm applying two conditions, has to be greater or equal to 18 and has to be less than 65. So now if it's 65, it will ignore this particular condition. It will ignore this condition. It will jump directly here. Let's test it out. And yeah, I have a problem there because I forgot to put the operators here. Let's check the condition again. And it says you're senior. So as you can see, you can apply many of these things. Last thing I want to show you is the part where we can use the switch case. Now for switch case, I'm going to use the simple grade um, variable, and let's see if somebody has a grade C. All right, so in switch case, you can use switch and the grade. This is where your expression goes. Then you have a bunch of case statements here. If the case is A, uppercase A, then I'll do this. And I'll say you have an A grade. Okay, ENDL. And as indicated, it must end with a break statement. Unfortunately, that's how it is. And then if somebody has a case B, I'm not going to write all of them. I'll just write a couple of them. I'll just copy these here and paste them here. Change that to B. And let's just write one more. Case C. Bring this one here back. This one is case C. And this one is C. Okay. And finally, if none of these cases match, then you can go to default case. And you can say cout invalid, invalid grade. And then you can exit out and a break statement. So then your switch case ends right there, right there. Right? You can have many, many, many conditions here. Here we are checking for the C grade first. So the C grade is not going to match the first case. Nothing will happen here. It's not going to match the B. It's going to match this one here, and it will exit successfully after that one. And you can see you have a C grade. If I change that to A, need to stop this one first. If I change that to, notice that if I change to lowercase a, it's going to say invalid grade. So let's take a look. It's just giving me a hard time. It wants me to buy something here. I don't want to do that. I'm going to copy this code here, move to another compiler. And here's my code. I think you can see it. All right. So this time it's lowercase a. It shouldn't match with this one. And close this part here, all these advertisements. If I run the code and it says invalid grade. Now, how do I manage that one? I can manage that one by putting two cases. I can say case lowercase a. Now you have two different conditions you can check. So that should work as well. And you can do the same thing for the B as well. So if I run now, it says you have an A grade. Although I had lowercase a, but I was able to check both cases successfully right there. Okay. So hopefully you can finish this project, and this project will require some time. I do recommend you use scientific notation for this project. I forgot to show you. So scientific notation means that, for example, if your value for discriminant, let me just very quickly demonstrate it. If it's 4.5, for example, let me stop this one first. Let's say you have 4.5. And if I simply display discriminant, it's going to show me 4.5. Let's take a look. So if I display, it shows me 4.5. However, if I use cout, scientific, now if I run the code, it's going to show me the same answer in a scientific notation. All you have to say one time, and it is a fall through effect. It will be applicable for all double data types. Okay. This will help you to complete project number 4, and I'll see you in chapter number 5. Thank you.